going to talk about is using studies wisely. So this is basically all about deciding whether we can extrapolate the data further. So like if my survey where I asked you guys how often you worked and like nobody said they worked anything, if I went ahead and said the whole school doesn't work, that's bad use of it. But if I asked most of the school and then went and extrapolated further, sometimes that actually can work. So. Okay.
Well, like if you do,
I'll try and figure it out.
Okay.
I have like a question in my mind.
Okay. So. Random selection of individuals allows inference about the population from which the individuals were chosen. I haven't taken attendance. Road trip? We all fit in my car? I don't think we all fit on the Spirit bus. I think it only fits 12 people. The Spirit van? It's like, it's parked in it's a green van. Okay, so since we're talking about golf, I assume we're done writing. And then I can also say random assignment allows inference about cause and effect. Okay, so I don't know what I was thinking when I typed this up. I don't mean to have a giant space under that. We're not answering that question. This chart is answering that question. So, I don't know what I was thinking. And then I realized it after I printed it out, and I was like, whatever. Did anyone still need this to copy down? Okay, so this chart is how we can decide whether we can go further with our data. So, on the top, I have if the individuals were randomly assigned to the data, and if they were randomly selected from a population. So if they were randomly selected from a population and randomly assigned, then I can make inferences about the population. I could also make inferences about cause and effect, but this is rare in the real world, so I typically won't do that. Okay. So if they were not randomly assigned, but they were randomly selected, then I can still make inferences about the population, but I can't make inferences about cause and effect, because that could be confounding. So here I have if they were randomly assigned to groups, but they weren't randomly selected, then I cannot make inferences about the population. And I can make inferences about cause and effect. So this is applying to experiments mostly. Okay. The last one, if they weren't randomly assigned and they weren't randomly selected, I can't make inferences, and I can't, oh, they're both inferences. I can't make inferences about the population, and I can't make inferences about cause and effect. So think like observational studies or voluntary self-select. Okay. So below this, I have a few problems, and we need to decide if we can go further with the data, like how much we can say this data is valid for. So many students insist that they study better when listening to music. A teacher doubts this claim and suspects that students listening to music actually hurts their academic performance. Here are 4 possible study designs to address this question at our school. In each case, the response variable will be the student's GPA at the end of the semester. So our first thing is we can get all of the students in our AP Statistics class to participate in a study and ask them whether or not they study with music on and divide them into 2 groups based on their answer to this question. Then I could select a random sample of students at my school to participate in the study, ask them whether or not they study with music on, and divide them into 2 groups based on their answer to this question. 3 is to get all of the students in our AP Statistics class to participate in a study, randomly assign half the students to listen to music while studying for the entire semester, and have the remaining half abstain from listening to music while studying. And the 4th one is to select a random sample of students from our school to participate in the study, randomly assign half the students to listen to music while studying for the entire semester, and have the remaining half abstain from listening to music while studying. So, for each of these 4 designs, the mean GPA for students who listened to music while studying was significantly lower than the mean GPA of students who didn't listen to music while studying. What can we conclude about each design? So, again, I apologize for my weird spacing on this. We want to talk about each of these 4, and there's not very much room on the bottom. So we can use the back, because I'm not going to write too much on the back. So I'll answer number 1 down here, and then we'll write on the back for the rest. So on the first example, where we ask our students in this class whether or not they listen to music, what can we decide based on that? Can I go further and say that for all students this is true? In the first example, where everyone in the class selects themselves and is not randomly chosen? No. So I can only, for this data, I can only make the statement that this is true for students in this class.
That group only.
Mm-hmm. No, I can only tell you things about people in this classroom. It literally applies to only people you asked about. Okay, I'm gonna move on. Because Colin and Carter are talking about not this. Okay, so I'm gonna just write right below here. So for the second one, that one was the one where we're getting random students from the school, and we're dividing them based on what they do. So they're randomly selected, but not randomly assigned. This one, I can decide it goes to the entire school. But I can't decide if it's cause and effect. Mm-hmm. I don't like that piece. Much better. Okay. So the next one is the one where I'm picking everyone in this class, but I'm randomly assigning which ones can listen to music and which ones can't. This one, we can say there's a cause and effect relationship, but only for the students in the AP Stats class because they weren't randomly selected out of the school. And then the last one is randomly selecting students in the school and randomly telling them to listen to music or not. So this one, because it's totally random for both, I can conclude there is cause and effect. I wanted to say a cause. And it applies to the whole school. Okay, so questions on any of these? So at the top of this page, I have basic data ethics. It's not something that's tested on the AP test, but it is something that's good to know in case you want to run a study. So typically all planned studies must be reviewed in advance by an institutional board charged with protecting the safety and well-being of the subjects. So you can't do anything that's knowingly going to harm the subjects. So you can't run a study to see what chopping an arm off of someone does. It's not ethical. But you could run a study on people who have lost their arms. Okay. All individuals who are subject in a study must give their informed consent before data is collected. So you can't make someone participate in your study without their signed consent, basically. They have to know what they're agreeing to. Because, like, think of drug trials. Sometimes there's potential side effects, and they need to agree to those just in case.
This is experiments, right?
Mm-hmm.
Not studies.
No.
Not samples.
Yeah, just experiments. And then this last one, it applies to samples too. All individual data must be kept confidential. Only statistical summaries for groups of subjects may be made public. So let's say I was doing that drug trial and I learned that it makes half of you super sleepy. I can't release your specific names tied to that data because that's not ethical. So questions on any of that? Oh, I was like, I'm crazy.